everyone, I'm Tim Kington and this is Java for Beginners. Today we're going to look at the solution to the exercise I gave you last week, and then we're going to dig into if statements. At the end of the video last time, I asked you to try to write a program that would read three numbers from the user and take the average of the three numbers. So let's take a look at that. We had code like this last week where we created a scanner and closed it, and in between we can ask the user for input and read it from the user. So let's ask the user for three numbers. And I guess if we're going to take the average, maybe we should make these doubles. We could make them integers, that doesn't really matter. I'll say double. And then we'll ask for a second number. And we'll ask for a third number. And now, since we know we have three numbers, the calculation here is fixed. We know that the average is going to be the sum of the numbers divided by 3. So we'll print the average is, and then in here we can do a calculation. I'm going to put it in parentheses to control our order of operations here. If we do this, are we going to get the right answer? So first of all, let's not put the parentheses in and see what happens. We'll enter 2, 4, and 6. And the average should be 4. 2 plus 4 plus 6 is 12. 12 divided by 3 is 4. This did not come out the way we wanted it to. And this is for the same reason we discussed last time. The operations here are going to be done from left to right mostly. So the division will happen first. C divided by 3 is going to give us 2. C was 6. That's the third number we entered. So 6 divided by 3 is 2. And then the rest of these additions are going to happen left to right. So we're going to take the averages and add it to the number 2. And so the 2 will be converted to a string, 2.0, and concatenated with the string. We're going to get 2.0 here instead of just 2 because our variable was a double. So we get the average as 2.0, and then we're going to tack on the next number, 4.0, and then we're going to tack on the result of dividing C by 3. So we're going to get this weird looking string. Now if we put the parentheses in here like I was going to, things are going to be a little bit better. But we're still getting the wrong answer. The average is 8. So this time our numeric calculations were all done first because they're inside the parentheses. And then we added that onto our string. But the calculation was done incorrectly. We got the result of 8. What's going on there? Well, here it's an order of operations issue with the calculation. The division is happening first. So we're taking 6 divided by 3. That will be 2. And then we're going to add 2 plus 4 plus 2. And we get 8. So really we need to add our numbers up first and then divide by 3. And we'll actually get the average. And if we put in 2, 4, 6, now we get 4. And if we run this and we put in numbers where the average isn't going to come out exactly, 3 maybe, there we go. Now we can see that using doubles lets us get a fractional result. If you used integers, then the average would be truncated. So the decimal part of this number would have been removed by the division, and you would get the average as 3, which is close to right, but not exactly correct. All right, let's take a look at if statements. So I'm going to go ahead and switch over to a fresh project here. What are if statements all about? Well, if statements are how we let our program make decisions based on data. So if we don't want our program to do the same thing every time we run it, we want it to actually react to user input or maybe data that's coming in from some other source over the network or out of a file that we're reading, then we need if statements to make decisions. Let's start simple. We'll read a number from the user. And then we'll tell the user if it's a big number or not. We need our in.close to get rid of the warning. We need a message for the user to tell them to enter a number. And then here we're going to write an if statement. When we write an if statement, we're going to put parentheses around the if condition. The condition decides whether we're going to execute the code inside that if statement or not. So up until now, we've run our code from top to bottom, line by line. Now that we're introducing if statements, there will be cases where we don't run all the code. We're going to run one branch of an if or another. Maybe we'll skip over some code. Ifs are going to let us control that behavior. So the condition inside the if is what's going to decide whether we run the code inside the body of the if. So in this case, we're going to check if the number is a big number, and if it is, we will tell the user that. So our condition here is x is greater than 100. Now this is a new operator that we haven't seen. Last time we talked about the arithmetic operators. There are also a bunch of comparison operators in Java. Greater than and less than are just what you would expect. We also have greater than or equal, less than or equal. We have is equal, and then we have not equal. So these are your 6 basic comparison operators. In this case, we care if x is greater than 100. So if x is greater than 100, we will print, that's a big number. So in an if statement, we have our if, we have a condition that will be in parentheses, and this expression has to evaluate to true or false. So we can't put something in here like 3 plus 7. This can't just be any old expression. If we put an expression like that in here, the compiler will tell us, cannot convert from int to Boolean. So anything that is in our if condition is going to have to be a Boolean expression that evaluates to true or false. If it's true, we're going to run the body of the if statement. Technically, we don't need these braces here if our if statement's body is only one statement. So we could write the code like this, but it's good to get in the habit of including the braces. So we'll put the braces in here. We have the body of our if. Now the way this code's going to execute is that we will read a number from the user, and then if the if statement is true, we will run the code inside the if statement, and then continue with the next line. If the if statement's condition is false, we will not run the code in the body of the if statement. So let's go ahead and run this and see how it works. If we enter a number, and it's a large number, then the program prints that's a big number. If we run it again, and we put in a number below 100, nothing happens. So the if condition evaluated to false, and that meant that we did not run the code inside the if statement. So the program just exited. Often we want to do something whether the if is true or not. We want to do different things based on whether the if is true. So here we can add an else block, and we can put some code in here that will run when the if statement was not true. So we'll say that's pretty small. Now if we run the code, when we enter a number greater than 100, the if will be true. We'll go inside the body of the if and execute this code. It will print that's a big number. And then it will skip over the else block and continue down here. So we put in a big number. It says that's a big number. It jumped over this code and then closed our scanner. Let's add another line of output here just so that we can see that's what's really happening. So if we put in 102 here, the if condition was true, so we ran this line of code. We skip over the else block, and then we pick up with the next line. So we print this is the end, and then end.close happens. If we put in a small number now, the if is false, which means we're going to execute the else block. So we print that's pretty small. Then we go on to the next piece of the code and print this is the end, and the program ends. What if we wanted to handle more than just these two conditions? Well, it turns out we can chain if-else blocks together as many times as we like. So we can say if x is greater than 100, it's a big number. Then we could say else if and have a condition here. And now this code will only execute if the second if condition was true. So we could say if x is less than 50, that's a small number. And we can add another else on the end here that will be sort of a catch-all if neither of the other conditions were true. So here we'll say, nah. All right, so if x is greater than 100, we're going to print that's a big number. And then we're going to skip the rest of the if statement. So we'll skip over the code for this else if, and we'll skip over the code for the else, and we'll jump down here. If x is less than 50, then this will be false, so we'll skip over this case. Then we'll check if x is less than 50, and this will be true, and that means we'll run this code. And then we'll skip over the rest of the if statement. If x is between 50 and 100, then this will not be true, so we'll skip over this case. This will not be true, so we'll skip over the second case. And then we hit the else block, which is going to run if nothing else was true. So let's try this out, just prove that it works. We put in a large number. It says that's a big number. If we put in a small number, it tells us that. And if we put in a medium number, then we get meh. And we can make this chain of if-else's as long as we like. We could add lots of different conditions. And when we're doing this with if, else if, else if, else if, and then the last case is an else, only one of these can execute. If we separate these like so, now more than one of these will execute. So when they're chained together, this is one big statement that's checking a bunch of different conditions. If we break them up, then more than one condition can execute. Okay, so let's think about what's going to happen if we run this code. If our number is greater than 100, we'll print that's a big number. Then we're going to run this statement completely independent of the first one. If we entered a large number, this will have printed, and then x is less than 50 will be false. So we will run the else block. So when we put in a big number here, we're going to get that's a big number, and then meh. And then this is the end. Just to confirm, that's what happens. What happens if we enter a small number? Okay, 23. This will be false, so we don't print this. This will be true, so we print that's pretty small. And then we skip the rest of this if block, this if statement. What if we put in a middle number? Okay, now we're only going to get meh. So here, this was false. X is not greater than 100, so we don't print that. X is not less than 50, so we don't do this. And then the else case is going to run, so we print meh. So it's important to think about whether your ifs need to be connected or not, depending on what you're trying to do in the code. So far, all of our if statements have had single lines of code in the body. But that's not required. We can put as much code into the body of an if as we want. Let's add some more code here so that we can see that's true. All right, so here we've just added a line of code to each of our cases, and the flow of the code isn't really going to change. The difference is when x is greater than 100, now we're going to run both of these lines of code. The body of the if goes from the brace after the if to the closing brace that matches it. So we're going to run all the code in between those two braces when the if is true. And the same goes for our else block. So here, if we put in a big number, we should see both of these lines of output. And then we'll see meh because we currently have broken code, right? We could fix our if statement. So we're actually seeing that's a big number in second thing, and then we're seeing meh and second meh. We can fix our if statement back to the one that actually made sense here. And now we'll only see one of the three cases each time. So we put in 123, we see that's a big number in second thing. If we put in, say, 66, we see meh and second meh. All right, so we can have as much code as we want inside each branch of the if statement. We've been looking at the comparison operators like less than and greater than so far, but there are some Boolean operators that are also useful when we're dealing with if statements. We have a Boolean AND operator, which is 2 ampersands, and we have an OR operator, which is 2 pipes. We can use those to combine sub-expressions inside the condition of our if. Let's take a look at that. So if we write an if Let's say we want to find out if we have numbers between 50 and 100. We can say if x is greater than 50 and x is less than 100. So this will only execute if both parts of this expression are true, right? So if x is less than 50 or greater than 100, then this will not happen. So let's run this code. And we can try 123, and you'll see that it does not print meh. If we try a low number, 23, it also will not. If we try a number between 50 and 100, then we get meh in our output. Now we can combine as many sub-expressions as we want this way. So we could have really long, complicated if conditions. We could say and, maybe x is even, which would be x mod 2 equals 0. You could chain a whole bunch of stuff together. We can also use or. So if we use two pipes here, this will be an or. Now it doesn't make much sense to say if x is greater than 50 or less than 100 because that will always be true. So let's change this. We'll say if x is greater than 100 or x is less than 50, then we'll print extreme. All right, so now this one's going to trigger for large or small numbers, but not numbers in the middle. All right, so 123 does trigger it, 66 will not. We can combine ands and ors in here, and we can make this as complicated as we like. If we're combining ands and ors, maybe we have some other expression like this. It's not easy to remember which of these is going to happen first because of the order of operations. So it's best to put some parentheses in here and make sure it's clear to anyone reading the code what's going on. So here we're saying if x is greater than 100 or it's less than 50, and it's greater than 234. So that doesn't really make much sense. But we can combine these sub-expressions in any way that we like. We can also make things more complicated by putting if statements inside of our if statements. So we could say if x is greater than 100, and then inside this if we could have another set of conditions. So if x is less than 200, we could print a certain thing. I guess I'll just say 100 to 200 so we know what's going on. And we could have an else here. And then in the else, we could print 200 plus. And then over here, we could have a whole other set of conditions. Right? So here we could say just less than or equal to 100, which is what is really happening. I guess this is greater than 100, so it's 101 to 200. And this is going to work just like the other if statement. Now, what's going to control which if statement this else belongs to? The else is going to belong to the last if that did not already have an else. So this else will belong to this if. This else will belong to this if. In this case, we also know which if the else's belong to because this else is inside the braces for the outer if. So since it's completely enclosed in these two braces, it can't belong to the outer if. It's inside of it. So it's clear which ones are connected here for two different reasons. It's a good idea to keep your code indented correctly so you can tell which ifs go with which else's. The way I tend to do it is I line up the if with the close brace for the if and then the close brace for the else on that if. Those are all on the same line here, or same column. And this if lines up with the close brace for it and the close brace for its else. You don't have to do that. The compiler doesn't care, but humans who are trying to read your code will thank you if you line your code up correctly. All right, this next bit's a little complicated, so I needed to call in an expert. Daisy's going to help us out. Now let's take what we've learned so far and try to solve a more difficult problem. Let's ask the user for a year, and then we'll write some code to try to tell whether that year is a leap year or not. So we'll read a year from the user. Now to check whether a year is a leap year, the first thing we need to do is see if it's divisible by 4. The modulus operator that we talked about a little while ago is good for that. So if we say year mod 4, this is going to divide the year by 4 and give us the remainder. So if the year divides evenly, the remainder will be 0. we can compare that remainder to 0. So if when we divide year by 4, the remainder is equal to 0, then this is a leap year. All right, and if it's not a leap year, we'll print nothing special. Okay, so let's run this. See that that modulus works the way that we expect it to. So 2021 is not a leap year. 2020 is a leap year. Notice that we're using the equal sign in two different ways here. In Java, we can use a single equal for assignment. So here we're taking a value from the right side and we're assigning it to a variable on the left. And we can use a double equal for comparison. This is going to check and see if the left side and right side are the same. And if they are, then the whole expression will evaluate to true. If not, it will evaluate to false. It's a common mistake to put a single equal sign into an if statement, and you get a very unhelpful error here. Syntax error on token equals less than or equal expected. What this is really trying to tell you is this assignment doesn't work. You can't take 0 and store it in a variable on the left side. Your left side here is not a variable. This is an expression that evaluates to a number. So this isn't going to work. We need two equal signs when we want to compare two values. Daisy tells me that leap years are not this simple. Years that are divisible by 100 are not leap years unless they're also divisible by 400. So we need to add some more logic here if we want to get this right. A lot of the power of programming comes from the fact that you can combine all the different pieces that we're learning in pretty much any way you want. So we can build expressions out of smaller expressions and make the expressions as complicated as we like. We can mix statements and if statements together. We can nest if statements inside of each other. And soon we'll learn a few more tools that we can combine with these, and then we'll literally be able to calculate anything that can be calculated. All right, so here we can add an if statement inside of our other if statement. So if the year is divisible by 4, now we want to check if it's also divisible by 100. So we can use the modulus operator to do this. And if the year is divisible by 100, then it's not a leap year. So we'll say almost a leap year. Now I've made a mistake here. This is a really common mistake. So let's run the code and see what happens and then see if we can figure out where it is. So if we put in a number like 2021 here, this first if will be false. And the braces for this if define where it begins and ends. Now if we put our cursor on this brace, VS Code is very helpful and highlights the matching brace. This will always be correct. If you indent your code correctly, you can also see visually where the if ends. So I tend to line my ifs up with the closing brace for the if and the closing brace for the else block on that if. That way you can sort of scan down here and see what's going to happen as your code runs. So if this is false, we're going to jump down to this else and we'll print nothing special. That really hasn't changed. If the year is divisible by 4, we now have some extra logic here. So let's try a number that's divisible by 4 and 100. So we'll say 2000. All right, this printed almost a leap year, and it's a leap year. This is the mistake I was talking about. In here, once the year is divisible by 4, we're checking if it's divisible by 100 and printing almost a leap year. But we're also going to print it's a leap year. This line is not inside of a second if statement or else block. So this is always going to print if we get inside the first if. So if the year is divisible by 4, we're always going to print this line. Sometimes we'll also print the line almost a leap year when the year is divisible by 100 as well. So here for 2000, we got 2 lines of output, which is wrong. If we run the code and we put in a number that's divisible by 4 but not 100, it will still say it's a leap year. So what we want is for only one of these lines to ever be printed. And that's why we need another else block. So if the year is divisible by 100, we'll say almost a leap year. If it's not, then we want to say it's a leap year. So let's run this, try those two values again. So 2020 is a leap year, 2000, almost a leap year. All right, this seems to be working correctly. This isn't quite all the logic we need though. We still need to worry about the years that are divisible by 400 as well. So we can add another if inside here. So if the year is divisible by 4 and 100 and 400, then it is actually a leap year. And we don't want to make the same mistake again here, so we will put an else block in and move our almost a leap year inside of that. This code's starting to get pretty complicated. We can test it and try to see that it works correctly, but it's going to be hard to be sure. Every if we have here introduces two separate paths into our code, right? We have the if block and we have the else block, and then we have another if with an else and another if with an else. If we're nesting ifs like this, we can wind up with an exponential explosion of possibilities. In this case, we have 1, 2, 3, 4 branches that can run, and a bunch of different conditions that we would have to check to make sure everything works correctly. We'll just try 4 years. We're not going to exhaustively prove that this code is correct. A little bit later on, we'll talk about unit testing, which is really the right way to prove that something like this works. We can write automated tests that would exercise a bunch of different possibilities and make sure that we get the correct results. We don't quite have the foundation that we need for unit testing yet. We still need to learn about method calls and classes a little bit. We'll get to that soon. Okay, so a year like 2021 should not be a leap year, nothing special. 2020 is a leap year. 1900 is divisible by 4 and 100, but not 400, so it should not be a leap year. And then 2000 is one of those special years that's divisible by 400 as well, and so it is a leap year. It looks like this code is working. Here we use nested if statements to get this logic to work. There is another way we can do it. We can try to write a single expression that checks whether the year is a leap year or not. So let's get rid of some of this code. We still want some code that will print it's a leap year, and we want code that prints nothing special. And then what we need to do is come up with an expression in this if, that when it's true, it is a leap year, and if it's false, it is not a leap year. We're going to start by checking whether the year is divisible by 4. So if year mod 4 is equal to 0, then most of the time it will be a leap year. We need to exclude years that are divisible by 100. So we'll say, and the year divided by 100 is not equal to 0. And we also need to check whether the year is divisible by 400. So we'll put in a year mod 400 is equal to 0. And I believe we need some parentheses here to get this to work right. So if the year is divisible by 4, and either it's not divisible by 100 or it is divisible by 400, then this is going to be a leap year. Now this kind of expression is very hard to understand. It's very hard to look at this and imagine every case and be sure that it's going to give us the correct results. I've been doing this for a long time, and I'm only about 90% sure that I got this right. One thing we can do is test it. So let's go ahead and run it and see what it does, and then I'll explain the logic of that expression. So 2021, not a leap year. 2020 is a leap year. 1900, not a leap year. 2000 is a leap year. So it looks like I got this right. Again, if we had unit testing, we could write some tests and try a bunch of values and be a little bit more confident. But I feel pretty good right now. I'd say 99% that this is correct. How does this expression work? Well, first, let's review our operators a little bit. So we have equal equal here on the left. We can say x equal equal y. This will be true when the two values are equal, and it will be false when they're not. We have a not equal operator in the middle. If we say something like x is not equal to y, this will be true when the values are different and false when they're the same. We also have our and our or in here, so we're using our and operator and our or operator. If we say A and B, this will be true only if A and B are both true. So if A is false or B is false, this whole thing will be false. A or B is going to be true when A or B or both are true. So as long as one or the other is true, this whole thing is true. It's only false when A is false and B is false. And we're putting this together into a complicated expression. let's think about what happens when we plug in these different numbers. So when we put in 2021, the first part of our expression is going to be false. So year mod 4 is not going to be equal to 0. 2021 is not divisible by 4. So this left-hand part of our AND is false. And that means we don't even need to look at the right side of the AND. For an AND to be true, both sides must be true. That means that once the VM checks this left side of our expression, it already knows the whole thing is going to be false, and it's not even going to do the calculation on the right. So for 2021, we know this is false, so the whole expression is false, and then we go to the else block and print nothing special. For 2020, the year is divisible by 4, so now we need to check the right side of the AND to see if it's also true. We check if the year is divisible by 100 next. 2020 is not, obviously. And so this part will be true. And since this is true, we know that the OR is going to be true. Remember, when we OR things together, if either one or both are true, then the whole thing is true. So again, the VM is going to shortcut. That's what that's called when you only evaluate part of an expression. So let's start over again. This is so confusing. It's really hard to keep these pieces in your head. 2020, divisible by 4, so this is true. Not divisible by 100, so this is true. And that means our whole expression will be true because true or anything is true. And then we have true, and that is true. So we print it's a leap year. Now for 1900, the left side is true. Our year is divisible by 4. The year is divisible by 100. So this part is false. Notice this is negative logic. We're saying it's not equal to 0, so it's not divisible by 100. So 1900 is divisible, which makes this part of our expression false. And now we have false or something, so we do need to check the right side, because if the right side is true, then our OR will still be true. So now we check if 1900 is divisible by 400, and it isn't. So we got false here, we got false here. False or false is still false. And then we had true and false, which is false. So it is not a leap year. For 1900, we print nothing special. And then our final case, if you're still with me, is 2000. 2000 is divisible by 4. This is true, so we have to check the right side. It is divisible by 100, so this is false. And it is divisible by 400, so this is true. False or true is true. And then we have true and true is true. So we print it's a leap year. To work through this a little more systematically, or if you really wanted to work this out on paper, you can do it much like you might have in math class. We can substitute values here. So let's do the 1900 example. I think that was one of the confusing ones. We can write this expression out and we can plug in values as we compute things. So year mod 4 equals 0. 1900 is divisible by 4. So this whole thing turns into true. All right, so we can write this as true and then in parentheses, we'll figure out 1900 divided by 100 is going to give us a remainder of 0. So this will be false because it was a not equal to 0, right? We could even do this one more level. We could say year mod 100 for 1900 is 0 and say not equal to 0. Or, and then 1900 mod 400 is going to be 300. So we could say 300 is equal to 0. And then we could substitute again here. So we could say true and. Now 0 is not equal to 0. That's obviously false because 0 is equal to 0. So this is false. Or 300 is equal to 0. Well, that's false. And now we can say, all right, we have true and now false or false is still false. And then if we say true and false, this is going to be false because for an and to be true, we need both sides to be true. So you can work through and you can plug things in and substitute and work your way down until you get a single Boolean value of true or false. Much like you would have in math class, you just keep simplifying the expression. It takes a lot of practice to be able to look at something like this in the code and be able to do this substitution and figure it all out in your head. And if you really want to be able to write this code and know that it works, you have to do this for sort of all possible combinations at once. That's why it's really hard to write code like this and get it right. If you don't have tests, you really can't be confident that your expression is correct. Well, we covered quite a lot of ground there today. We talked about if statements, we looked at a couple of new kinds of operators. We got to see comparison operators and logical operators in action. And then we attacked a fairly complicated problem. You can see why programmers hate dealing with dates. There were two ways we could handle this. We looked at nested if statements, and then we looked at making our if condition a lot more complicated. Either way can work. As an exercise, try writing some code that will ask the user for a temperature, and then print out the state of water at that temperature. It could print liquid, solid, or gas, depending on the temperature the user entered. Don't forget to like and subscribe. Next time, we'll talk about switch statements.